For this example, we are given three absolute value functions, and they have something in common. All three of these are the parent function. This picture here just shifted left, right, up, or down. They're not going to be more narrow or wider than the parent absolute value function because there's no number in the very front of the absolute value symbols, and then there's no negative to reflect it. So finding the vertex is really easy. If you look at the generic form of the function here, circled, to find the vertex, it relates to finding the vertex of quadratics. So to get the first coordinate, all you do is take the sign of what's inside the parentheses here next to the h and flip it. So if it's a minus h, it becomes positive h, and then the back number stays identical. So if I look at my first example, this is a -3, so flip that sign to a +3, and then the back number 2 stays the same. So domain is your x values. What x values are you allowed to plug in if you're making a t-chart? You could technically plug in any x value. And if you would graph it, again, graphing your absolute value function would be starting with the vertex at 3, 2. So I'm just going to shift 3 to the right and up 2. I'm just going to estimate that there, and then it's the parent function, so it's going to be going up. So if I look at the smallest x value and the largest x value, this V shape covers both sides of the graph because it eventually opens left and right forever. So it's -infinity to +infinity. The smaller number goes first, so I wrote -infinity, and then the larger number goes second, which is +infinity. So the y values. So again, you have to start with the lowest y value. So if I look at my picture here, what is the lowest y value? Well, remember, we graphed the vertex at 3, 2. So if I travel up the y-axis, this would be 2 units, right? So the lowest y value is 2, and then the highest y value, since this travels up forever, these arrows go up forever, that means it would be +infinity. So there's two ways to write this. You could write 2, infinity. The 2 gets a bracket because you're including it, and the infinity symbol gets a parenthesis because infinity is not an actual number. It's more of a concept. However, you could write it a second way. To say the y values are anything greater or equal to 2, you could say f of x, which is the same thing as the y values, are greater than or equal to 2. For this next picture, finding the vertex, again, flip the sign of what's inside the parentheses. So instead of +5, it's -5, and the back number stays the same. The domain is going to be the same for these next two, so -infinity to +infinity. And then the range depends on the picture. So if I graph -5, -1, I'm going to estimate that right there. So it's my V shape going up. Again, it's just the parent function shifted 5 to the left and down 1 from the origin. So again, what is the lowest y value? Because that's what you have to consider first. The lowest y value here is -1, right? So the lowest is -1, and then because the V shape goes up forever, it goes to infinity. So I'm going to write this two different ways. So the lowest was -1, comma, and then the highest is infinity. Or you could say f of x, the y values, are greater than or equal to -1. For this last example, my vertex, just flip the sign, -4, and the y coordinate of the vertex is +3. So again, I just flip the sign of what's inside the parenthesis, back number stays the same. My domain, all real numbers, -infinity to +infinity. I could plug in any number I want for x to make a t-chart. And then my range, if you think of graphing it, you would, from the origin, shift 4 to the left and then up 3. So we'll say that's about right here. So the lowest y value, well, if I plotted the vertex at -4, 3, this would have been the 3. So it starts at 3 and then goes up forever. So 3, infinity. Or you could say the y values, which are the same thing as f of x, is greater than or equal to 3.